So we've already seen some examples of a normal distribution function for some of the examples in this course. That's an example of a probability density function, and there are other types of probability density functions out there. So let's dive in and see what it really means and what some other examples of them are. Let's talk about probability density functions, and we've actually used this already in the course, we just didn't call it that. So let's formalize some of the stuff that we've talked about. For example, we saw the normal distribution a few times in our examples, and that is an example of a probability density function. Here's that normal distribution curve. So, it's easy conceptually to try to think of this as the probability of a given value occurring, but that's a little bit misleading when you're talking about continuous data, right? Because there's an infinite number of actual possible data points in a continuous data distribution. There could be 0 or 0.001 or 0.00001, right? So the actual probability of a very specific value happening is very, very small, infinitely small. The probability density function really speaks to the probability of a given range of values occurring. So that's the way you got to think about it. So for example, in a normal distribution, between the mean and one standard deviation from the mean, there's a 34.1% chance, it turns out, of a value falling in that range. And you can tighten this up or spread it out as much as you want and figure out the actual values, but that's the way to think about a probability density function. For a given range of values, it gives you a way of finding out the probability of that range occurring, okay? So you can see here, as you get close to the mean within one standard deviation, you're pretty likely to get there. I mean, if you add up 34 and 34, whatever that comes out to is the probability of landing within one standard deviation of the mean. But as you get out here between 2 and 3 standard deviations, we're down to just a little bit over 4% combined with the positive and negative. And as you get out beyond 3 standard deviations, then we're much less than 1%, actually. So it's just a way to visualize and talk about the probabilities of a given data point happening. So again, a probability distribution function gives you the probability of a data point falling within some given range of a given value. Okay, and a normal function is just one example of a probability density function. We'll look at some more in a moment. Now, when you're dealing with discrete data, that little nuance about having infinite numbers of possible values goes away, right? And we call that something different. So that is a probability mass function. If you're dealing with discrete data, you can talk about probability mass function. So, for example, you can plot a normal probability density function of continuous data on this black curve. But if we were to quantize that into a discrete data set, like we would do with a histogram, we can say the number 3 occurs some set number of times, really. And we can actually say the number 3 has a little over than 30% chance of occurring. So probability mass function is the way that we visualize the probability of discrete data occurring. And it looks a lot like a histogram because it basically is a histogram, okay? So terminology difference, probability density function, a solid curve that describes the probability of a range of values happening with continuous data. Probability mass function is the probabilities of given discrete values occurring in a data set, okay? So let's look at some actual examples, and it'll make even more sense, and we'll go into some more depth next.